In this example, I'm going to go over how to generate a sample space. When making an ice cream sundae, you have a choice of 4 types of ice cream flavors: chocolate, vanilla, mousse tracks, or dark chocolate, a choice of 3 types of sauces: hot fudge, butterscotch, or strawberry, and a choice of 2 types of toppings: whipped cream or fruit. If you're choosing only one of each, list the sample space regarding the sundaes you could pick from. So what they want is all possible combinations here. So I'm going to do this using a sort of a tree diagram. So first I have my ice cream flavors. I have chocolate, vanilla, mousse tracks, and dark. So those are my 4 ice cream flavors. All right, so if I were to choose chocolate, then I could choose 3 sauces, and that would be the hot fudge, the butterscotch, or the strawberries. So I could have chocolate with hot fudge, chocolate with butterscotch, chocolate with strawberry. Now clearly I'm not done. I can do the same thing for the vanilla. I could have vanilla and then hot fudge, vanilla with butterscotch, and vanilla with strawberry. So each of these ice creams will have 3 branches coming off. But then we also have 2 toppings. So I could go ahead and finish that. I'm going to go ahead and go on to the toppings. So this is the sauce. So we've got 3 of those. And then 2 toppings. So I could have chocolate, hot fudge, and then 2 toppings branching off of there, and that's whipped cream or fruit. So following the path, I could have chocolate with hot fudge and whipped cream, or chocolate with hot fudge with fruit. Okay, clearly that is not my only option. I could follow this path. I could have chocolate with butterscotch and then have 2 branches coming off of that with whipped cream and fruit, or chocolate, strawberry, and then 2 branches with whipped cream or fruit. So in generating the sample space, I'm just following these paths. Okay, so my first one will be chocolate, hot fudge, whipped cream, so CHW, and then comma, and then I'll have CHF, and then CBW, whoops, CBW, and then CBF, and then I can do the same pathways for chocolate and then strawberry whipped cream, chocolate, strawberry, fruit. Okay, so that will be all of them for the chocolate. Okay, but chocolate is not the only option I can have. So I could have vanilla with these 3 toppings, and then each of these 3, and I'm running out of room here, will have 2 branches coming out. So to write that out, that sample space, I would just follow each of these little pathways. Okay, so again, I wouldn't just stop at completing these branches for vanilla. I would do the same for mousse tracks and dark chocolate. So all together, it would look like this. Okay, so you'll see that each of the ice creams has their corresponding branches coming out. And I wrote out all of the options. Now, as I said in the beginning of the video, I expected to have 24 of these. Now, how did I know that? Well, I used something called the fundamental counting principle, which is typically covered in the same chapter or section that tree diagrams or generating sample spaces is covered. So I'm going to go ahead and include that here. So the fundamental counting principle, or I'll abbreviate it with FCP, states in general that the total number of ways you can generate a sample space or count how many outcomes you'll have is that you break it down into your events and you multiply across. So here I'm going to create 3 little slots because I'm actually doing 3 things. I'm choosing an ice cream, then I'm choosing a topping. Oops, sorry, the sauce comes next. Choosing a sauce and then choosing a topping. And like I said, you multiply in between each of these individual events. So how many ways can I select an ice cream? Well, there's 4 ways, so I put a 4 in here. How many ways can I select a sauce? I've got 3 of those. And then I have 2 toppings. And again, I'm multiplying straight across. 4 times 3 is 12. 12 times 2 is 24. So there's 24 possible sundaes you can generate. Now, the fundamental counting principle just gives you how big your sample space is. It doesn't actually list everything out systematically. But in probability, we're typically not concerned with looking at the actual outcomes in the sample space. We are looking at how many we have in the sample space.